trying to find some level of motivation for this. This was like the most annoying lesson to prepare. This is, I don't even know, Unit 3, Lesson something, horizontal shifts. It's the exact same thing we did in the last lesson, but instead of moving up and down, we're moving left and right, and it just takes forever to teach you something very simple. So now we're dealing with the formula y equals f, and then we have parentheses x plus k, where k is the number of units the function is translated to the left. Okay, so if it's plus k, it's moving to the left. Horizontal shifts move the opposite direction of the positive or negative sign. So on the x-axis, the positive numbers are over here on the right, and the negative numbers are over here on the left. So you would normally think, oh, plus k, then I'm going over to the right. Nope, you're going to the left. X wants to be on the x-axis. It wants to be oppositional. It wants to be contrary. So just remember that if it says plus k, we're going in the opposite direction. We're going to the left. Okay, this is the only thing that's tricky about this. Steps to graph the function. First, you select input values for the input variable. Then you evaluate the function using the input values to determine the output values. Then you write the input and output value. I'm yawning. Output values as an ordered pair. Input value, comma, output value, so x, y. You plot the ordered pairs, connect the plotted points, and label the graph, and you repeat these steps for the translated function. It takes more time to read this than it does to do everything. Here's example number 1. Use a table and a graph to show that the translation of f of x is equal to x plus 1 squared, and its parent function f of x is equal to x squared. So we have two different tables. We have the translated one, and we have the parent function. Okay. These are the points that they chose for our x values, -2, -1, 0, 1, and 2. They're going to be the same for both tables. So how you would figure out what your f of x or y values are is very simple. You would just take your x value. You would choose which one of these you're going to do. So we'll do the more complicated one just so I can show you. You'd do f of x is equal to x. Our first x is -2. So that goes in parentheses to make sure we keep the negative with the number, plus 1, and all of that's going to get squared. Okay, so -2 plus 1 gives us -1. That's still in parentheses squared because this negative has to be part of the squaring. -1 times -1 becomes +1. So our value right there is 1. Okay, you would do that all the way down this one. And then for the parent function, it's just x squared. So -2 times -2 becomes 4. -1 times -1 becomes 1. Okay, and you end up filling out both of your tables with all of your values. Then you take these are now coordinate pairs. So this first point is -2, 4, and you would graph each of these. So here is our parent function. You know it's the parent function because it touches the origin 0, 0. Okay, so the x-intercept and the y-intercept are both 0 for the parent function. You can see it's the parent function because it's written right there, but we also know that parent functions always touch or cross through the origin. This translated function, okay, is right here, and it shows that plus 1 means it moved the opposite direction over here to -1. Okay, so it moved left 1 space. That's what this means. That's the only number that matters. Okay, don't worry about anything else. So these tables illustrate, these tables are different. So if you look here, our x values stayed the same. Over here, what they did was they kept the y values the same, because what changes when we're shifting side to side is the x values. So if we use x values that have been shifted 1 unit to the left, we know that's what's going to happen. It's being shifted left 1 because we can see that information. So if we keep the same y values and we just shift these left 1 unit, so if we're already at -2 and we go 1 more to the left, it's -3. If we're at -1, we go 1 more to the left, we're at -2. That's all they did. The y values of the graph will remain the same. Okay, so if we do what this formula is telling us to do and move 1 to the left, then we can keep all of our x values the same. Okay, so here's practice question number 1. This is at the end of the lesson. Just write your answers down and you can fill it in later. So complete the tables to show the parent function y equals f of x and its translation y equals f of x plus 5. Okay, and that gives you all of this information. So what we need to do is we need to figure out how to fill in these values on this table right here. This answer should be -7 because we're already at -2. And if we move 5 more, 1, 2, 3, 4, 5, guess what? That's going to put us over here at -7. This is the value, okay? We're not going to make this complicated. We're going to work smarter and not harder. If you're at -2 and we know that we're moving left 5, then you're going to take your -2 and subtract 5 to get -7, okay? If we're already at -1, we're going to subtract 5 and that's going to give us -6. If we're at 0, we're going to subtract 5. That's going to give us -5. If we're at 1, we're going to subtract 5. Now this can be a little bit tricky. Okay, we're going to go 1, 2, 3, 4, 5. We're actually at 1, 2, 3, -4. You have to count that 0 space. Don't forget to do that. Okay. And if we're at 2, 1, 2, and we're going left 5, 1, 2, 3, 4, 5, we're right here at -3. Okay. Now, I don't know if this makes sense because this one, no, it does because it's just -2, -1, 0, 1, 2. Okay, so this should be your correct answer. Okay, so here's example 2. Use a table and a graph to show how f of x equals x plus 2 cubed has been translated from the parent function f of x equals x cubed. So you can see the difference between this here, this formula, and this one is this plus 2. This is the only thing that matters, okay? Simplify it. Don't make it harder than it has to be. Plus means it's going left, and the 2 means it's going 2 spaces, okay? So we have here all of our values. We have our x values, and we don't have any f of x values. Okay, so we need to solve for f of x. Let's start with the parent one because it's going to be the easiest. So if we have f of x is equal to x, which our first one is -2 cubed. -2 times -2 is +4 times -2 is -8. Okay. So all we're going to do is cube each of these values all the way down. -1 times -1 is +1 times -1 is still -1. 0 times 0 times 0 is 0. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. Okay, here's our parent function. We got that done, no problem whatsoever. Now, we established that the difference here is this +2, which means it's going left 2 spaces. Okay, and what's changing here is the x value. The x value is what's moving left. But we can't do that here. We can't just say, well, okay, then -8 is now -6 because this is actually the y value and it's not what's changing, okay? It's the x value that's changing. So if x is -2 and we're using this formula, then what is our translated function? That's what we're trying to figure out, okay? Okay, I think I figured out how to do this. We're going to see if I'm smart enough to do this. So I need to erase my little marks here so that I can see what I'm doing. So we have our x value and we're trying to solve for f of x of this formula, okay? So we have f of x is equal to, we have our first x, which is -2, plus 2, all of that cubed. So -2 plus 2 becomes 0 cubed, and 0 cubed is just 0. Okay, let's go to our next one. We have -1, so f of x is equal to -1 plus 2 cubed. -1 plus 2 becomes +1 cubed, which gives us just 1. Okay. Let's go to the next one. So we have x is 0 plus 2 cubed, which is going to be just 2. 2 cubed is 8. Okay, and you would continue that all the way down. These are the numbers that you're going to end up with. Now, use a table and a graph to show how f of x equals x plus 2 cubed has been translated from its parent function. We did that. That's all we had to do. I'm not sure what... Oh, it erased. I finally got the right graphs on here. You can see this is the parent function because it crosses through the origin at 0, 0. And this one has been moved left 2 spaces, which is exactly what we should see with that change of plus 2. Here's a check-in. What is the result of graphing a function in the form y equals f of x plus k, where k is positive? When k is positive, the horizontal shift is to the left. Remember that on the x-axis, the direction you move for k is opposite what the sign says. X-axis, we're being oppositional. We're doing the opposite. It's being contrary, however you want to remember it. Now we're going to talk about horizontal shifts to the right. A horizontal shift to the right is a function in the form y equals f of x minus k, where k is in the number of units the function is translated to the right. Remember, even though k is negative in this case, the movement is to the right towards the positive x values. It's all opposite what it should normally be. Example number 3, use a table and a graph to show how the function f of x equals the square root of x minus 1 has been translated from its parent function f of x is equal to the square root of x. So the difference between this formula and this formula is this little minus 1. Minus 1 means it's going right because it's opposite, 1 space. Okay. So here's our 2 tables. So how you would fill these out is you would just enter our x value into the formula and solve. So for the parent function, it's f of x is equal to the square root of x. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. Okay. Now you're going to take each of these numbers and you're going to subtract 1 and then take the square root. So 0 minus 1 is negative 1. Okay, we can't take a square root of a negative. So maybe this is supposed to be outside of this and they wrote this wrong. In which case this would just be negative 1 and then this would be 0. So it's 1 less from each of these. This would be 1 and this would be 2. Let's go over here and see what they did. Oh no, they put the square root of negative 1. Okay, because you can't, it's undefined because it's a negative number. So I was right the first time. So square root of negative 1, 0, because you have x, which is 1, minus 1, which is 0. The square root of 0 is 0. Then you have 4 minus 1, which is 3, which is the square root of 3. 9 minus 1, which is 8, which is the square root of 8, because none of these have pretty nice numbers. Okay, here's example 4. The graph represents, oh, and the graph disappeared. Why does this hate me? The graph represents the function y equals the absolute value of x minus 2 after it has been translated to the right 4 units. So this is after it has been translated. Okay. After the horizontal translation, the translated function can be modeled by the equation y equals absolute value of x minus 4 minus 2. Use tables to represent the original function and the translated function using the same inputs. So again, this shows the translated function. You know, I thought this lesson was going to be so easy, and I must be really brain dead today because I'm just struggling. So we're using the same x coordinates. These are the ones that they chose for both of them. Let's start with this formula. We have y equals the absolute value of x minus 2. Our first x value is negative 3. So we'll put that in the absolute value signs. Oops, sorry. And put minus 2. So absolute value means this is going to be positive no matter what. So what we really have is positive 3 minus 2, which gives us 1. Okay. Now we're going to do it over here for this other formula, for this one right here. Doop, 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 doop. That sounds like a Mario song. Y equals the absolute value of x, which is still negative 3, minus 4, minus 2. So negative 3 minus 4 becomes negative 7, but it's in absolute value signs, so it's really positive 7 minus 2, which is going to give us 5 here. You would do this all the way down for both columns, okay, for both tables, and it's going to give you these points, okay? So what this tells us is one of these is going to be for this one is going to be for our first problem, which is really the untranslated one that's not shown here. And then this one is going to be for this one right here, okay? And we can double check that because we can say there should be a point on here that's negative 3, 5. Let's see. Negative 3, so 1, 2, 3, and then all the way up to 5. Yep, that's right there. There should be a negative 2, 5, so negative 1, 2, and it should be 4. But, you know, I probably typed that wrong. And then we should have negative 1 something. Let's do 0 and 2. Yep, that makes sense. So this one we're just going to assume is a 4, and I typed it wrong because, you know, I suck at life. That would follow the rest of the pattern really well. We should have 3 and negative 1, which is right there. Okay, so all of that passed the test except for the one that I mistyped. Okay, so that's example number 4. Here's another check-in. What is the result of graphing a function in the form y equals f of x minus k, where k is positive? Ignore that because k is not positive, it's a minus. This book has so many errors. A function that is in the form y equals f of x minus k means that it's going to be translated right. So minus is going to go opposite. So it's going to go to the right instead of the left. Everything is opposite for the x-axis. Question number 1, use a table. This is your turn. We have baby bread here. This is Ian. He has 2 different personalities. Today is baby bread. He's going to help us use a table and a graph to show the translation of f of x is equal to the cube root of x plus 3 and its parent function f of x is equal to the cube root of x. Use negative 8, negative 1, 0, 1, and 8 for your input values. The reason we're using these values is because they make nice cube roots, okay? So like the cube root of negative 8 is negative 2, okay? So go ahead and pause the video, go solve that. Make your tables, 2 tables, one for this formula, one for this formula, and then don't worry about the graphs. You don't have to make any graphs at the end that I recall, but I will show you how to do it on GeoGebra if we need to. Okay? Pause the video, go solve it. I will give you an example for each of these just so that you can understand how they got these answers. We'll start with our first formula, which is the translated one. So we go f of x is equal to the cube root of our first x value is negative 8 plus 3. Negative 8 plus 3 becomes negative 5. So we have the cube root of 5. Okay, so our first value on the table for this one should be the cube root of 5. Okay, let's do our next problem. And it says f of x is equal to the cube root of x. And our first x is negative 8. So our first value on this table should be negative 2. Okay, and here are all of those values. Okay, so you can check that. And there are graphs which did not show up. And here's what those 2 graphs should look like. So you can see that this graph applies here because here we have the negative 8, 2 point. And this graph applies here because here we have the negative 11, negative 2. So this one is the translated one that has been shifted. It says negative 1. So it should have been shifted this way. Okay, this is the parent function. This is the one that has been shifted and it got shifted. Okay, yeehaw, whatever. Question number 2. Use a table and a graph to show the translation of f of x is equal to x plus 1 squared and its parent function f of x is equal to x squared. Use negative 3, negative 2, negative 1, 0, 1, 2, and 3 for your x values. Pause the video and go do it. Okay, so again, I'll show you for each of these formulas. For the first one, how you would do it. So f of x is equal to x, which in this case is negative 3, plus 1 squared. So negative 3 plus 1 is negative 2. Negative 2 times negative 2 becomes positive 4. So the first value there is 4. Okay, so you would have negative 3 comma 4 for your first 2. For this one, it's f of x is equal to x squared, which is negative 3 squared. Negative 3 times negative 3 becomes positive 9. So this one would be negative 3 and 9. And here's what those look like. Negative 3, 9. And then they chose to keep the f of x values the same and change the x values. Okay? So this is what they got, which is not fair because they don't tell you here to keep the f of x values the same, but that's what they did. And then I'll go and get those stupid graphs for you that disappeared. And there's the two graphs that they got from these two tables, which again you could draw by hand by just plotting each of these points and connecting them, or you could use GeoGebra, whichever you prefer. Here is practice question 2 that will be at the end of the lesson. I have no idea why I have things. Oh, because it came early. I remember why. If y equals f of x is the original function, and y equals g of x is the horizontally translated function, by how many k units is the original function translated? Okay, so here we've got the same f of x and g of x values, so it's the x values that changed. So here we started at negative 1, and then we ended up at positive 3. So it moved 1, 2, 3, 4 units to the right, which means that your answer is going to be, do you know? If we went to the right, it's negative 4. That's your answer for that one. Okay. End of the lesson. This is quick check question 1. I will not give you this answer, but I'll tell you how to get there. Each of the function graphs represents an original function marked by a dotted line, blue, on the graph, and a translated graph marked by a solid orange line. Okay, so the blue is the first one. We're moving to orange. Which graph shows that y equals f of x minus 3 is the result of the function y equals f of x being translated by 3 units? Okay, there's two things you should look at first. We have very different graphs here. We have some that are like have a bend in the line, we have straight lines, and we have parabolas. If you look at the formula y equals f of x, you should be able to tell which shape it is and eliminate some graphs straight off from that. Then what you need to do is you need to go from blue to orange and figure out which way they're shifting, left or right, and which one shifted 3. Okay, you'll look at the x-intercept and see which one shifted 3 in the right direction, and then pick the correct graph. Okay, here's quick check question number 2, and the graph disappeared because my life is hard. Okay, which of the following correctly determines how many k units the parent function y equals x squared, shown as the solid line, okay, so this is the parent function, was translated? So it's being translated from here to here. So you have to figure out how many units it was translated and in what direction, if it was translated left or right. We're starting with orange, going to blue. Here's quick check question number 3, and no graph. Which of the following identifies the value of k that would correctly characterize the horizontal shift shown in the graph if the line to the left represents y equals f of x, and the line to the right represents y equals f of x minus k. So we're starting with this one, and we're moving to this one, okay? So which one shows the correct shift? How many units did it move? Pick the correct one. Next section, all horizontal shifts can be modeled by y equals f of x minus k. This is a complicated way of explaining why k moves opposite from the positive and negative values of x on the x-axis. If you're getting that, you know, if it says minus k, it needs to move to the right, and if it says plus k, it needs to move to the left. Don't worry about this, okay? But this is an explanation why. If we use this as the standard formula, and we say if k is less than 0, the shift is to the left, and if k is greater than 0, then the shift is to the right, it will explain a little bit better as we go along, okay? Steps to identify the horizontal shift k and the effect of the shift on the parent function. First, compare the equation of the given function and its parent function. Determine the differences. Second, compare the graph of the given function and its parent function. Determine the differences. And third, use the result from steps 1 and 2 to identify k and the effect of the horizontal shift on the parent function. This part of the lesson is very easy. Here's example 1. Use the graph, which doesn't exist, and the equation f of x is equal to x plus 2 squared to identify the horizontal shift k and the effect it has on the parent function. So let's look at just the formula first. So compare the two equations. Look, one is missing. Isn't that fun? To determine the differences. So down here it should be just f of x is equal to x squared. That's what this formula is. So the difference, really easy to determine, is this plus 2. That's the difference, okay? The next step is to compare the graphs and determine the difference. And look, the graphs are gone. Now that we have our graphs, you can see this is the parent function. It touches the origin, and it's shifted 2 to the left, which is exactly what we should see because it does the opposite. So it's minus 2, okay? It's going left 2. Then we're going to use the results from step 1 and step 2 to identify k and the effect of the horizontal shift on the parent function. Well, guess what? The value of k is the opposite. It's minus 2, okay? So k equals minus 2, and the effect is it went left 2, okay? It's that easy. And the value of k is negative 2, and the graph moved left 2 units. This is how easy this is. Example 2, use the graph and the equation f of x is equal to x plus 1 cubed to identify the horizontal shift k and the effect it has on the parent function f of x is equal to x cubed. So first we're going to compare the equations. The difference between this equation and this equation is this plus 1. Okay? Right now I can tell you what k is. K is equal to the opposite. So k is negative 1. Okay? Now we're going to look at the graphs, which, surprise, surprise, are not there. Okay, looking at these graphs, you can see the parent function crosses through the origin right there, and that the translated graph has moved left 1, which is exactly what we should see, the opposite. So it's left minus 1, okay? And look at this, we already did step 3. We already figured out what the value of k was and what it did to the graph. Here is example 3. Use the graph and the equation f of x is equal to x minus 2 squared to identify the horizontal shift k and the effect it has on the parent function f of x is equal to x squared. The difference in these two formulas is this minus 2. So we know that k is equal to the opposite, which is plus 2. Yay! And guess what? No graphs. Does that surprise you? And here's our two graphs. You can see the parent touches the origin, and the new one has moved to the right 2 units, which is exactly what we should see, the opposite. So plus 2 to the right 2. Okay, we already did all this. Example number 4, use the graph and the equation f of x is equal to x minus 3 to identify the horizontal shift k and the effect it has on the parent function f of x is equal to x, the square root of x. The only difference between these two is this minus 3. So k is equal to the opposite, which is plus 3. And look at this. Once again, I swear, this thing hates me. And here we can see the two graphs. The parent function touches the origin at 0, 0, and the translated one has been moved to the right 3, which we should see the exact opposite here, so plus 3. Okay? Here is example 3, because, you know, we have to keep doing this. The graph represents the function f of x is equal to 4x squared. How would the equation and the graph of the function compare with the original after a translation of 3 units to the right? Yay, we're moving on to something a little bit different. What it's asking now is, given this graph, okay, how would the function and the graph of the function compare with the original after a translation of 3 units to the right? So it wants to move it 3 units to the right, and it wants to know how's it going to change. Okay, it just wants us to talk through it basically. So what it's saying is, let's copy this and move it to our new page. Is the graph would show a quadratic function with the same shape. It's going to look exactly the same as the original, moved over 3 units to the right. So it's going to touch right here, but it's going to be the same shape, same slope, same everything. Okay. You can also just take each of these points and add 3 to each of the x coordinates. The y coordinates will stay the same. So this one is going to become 3, 0. This would be 2, 4. This would be 4, 4. Okay. And the new will look like this because it's going to have that minus 3 because it's moving to the right. So it has to be the opposite. Here's example number 6. The graph represents the function f of x is equal to the square root of x plus 2. How would the equation and the graph of the function compare with the original after a translation of 2 units to the left? So now we're moving the opposite direction. And again, it just wants us to walk through this, okay? So basically, what's going to happen is if we're moving it 2 units to the left, this point is going to be right over here. So all of these x coordinates, you're going to subtract 2. So this would be negative 2. And the y coordinate will stay the same, so this is positive 2. This would be negative 1 and 3. This would be 2 and 4. This would be 7 and 5. And everything else is going to stay the same. It's the same slope. Everything else is the same, okay? That's all that says. This is what the new formula would look like. So you'd still have your plus 2 from before, but underneath the square root, you'd also have a plus 2 because we shifted left, which is opposite, 2 spaces. This one's your turn. The graph represents the translated function f of x is equal to the absolute value of x plus 4. How is its graph different from the graph of the parent function f of x is equal to the absolute value of x? Okay, I got your graph back, so go ahead and pause the video, figure it out, and come back. Okay. I'm going to copy this because we're going to need it on the next page too because it hates me. So the parent function has been shifted to the left 4 units. You can see here. Oh, it's the same graph because I'm a Dorcas. So if we shift it left 4 units, it's going to go 1, 2, 3, 4, and it's going to be right here. And all of the units are going to be shifted that direction. Let me go get the new one. It didn't actually show us the new one, so I'm an even bigger dork. So you're going to subtract 4 from each of these x values. So this one would become negative 11, 3. This would be negative 10, 2. Okay. This is what the new formula is going to look like. So this is the original formula. F of x is equal to x plus 4, which it gave us over here. And then it's going to be x minus negative 4. This is more of the garbage of why the math says that we can use y equals f of x minus k. Don't worry about this unless you really need this explained. If you need this explained, comment and I will come back. But this is more complicated it has to be opposite. Don't worry about it. It's not worth it. Here's question 2. This is all you. And guess what it's missing? The graph. The most frustrating thing about this, down on my slides down below on my presenter's view, it shows that the graph's there. And then when you click on it, it comes up and there's no graph. The original function f of x is equal to x squared plus 1 is translated to the left 5 units. How would the graph of the equation of the translated function compare to the original, which is shown in the graph? So this is this formula right here, okay? They want to know if we shift this left 5 units, what's going to change? How is it going to change? What's it going to look like? Okay, so how would the graph of the equation of the translated function compare to the original, which is shown in the graph? So usually with these they have like multiple choice answers, but I didn't write any of that down and I don't know why. Basically, it's going to all of the y values, all of the x values, you're going to subtract 5. So this would be negative 8, 10. This would be negative 7, 5. This would be negative 6, 2. Okay, it's going to maintain the same size and shape, same slope. None of that's going to change. It's just getting shifted to the left. Here's practice question 3, which is going to be at the very end of your lesson. I can't tell you right now how much I hate this lesson. Notice the horizontal shift in the images. So we started here and we shifted over. What is the value of k for the horizontal shift that occurred between the graph of the original function y equals f of x and the graph of the translated function y equals f of x minus k? Just wants to know, what's the value of k? You should be able to tell me this. If you look here, we started at the origin 0, 0, and we moved over to negative 1, 0. So we moved left 1. So k equals the opposite. So it's not negative 1, it's positive 1. Oh my gosh, that was so hard. Practice question number 4 with no graphs, I swear. Okay, how far has the original function shifted horizontally? So this is the original one, okay? You can see the x-intercept is right here at negative 1. I'll blow that up so you can see. X-intercept is at negative 1, okay? Now our x-intercept is at positive 1. Okay, so how far has the original function shifted? If we start at negative 1 and we go to positive 1, we went 1, 2 units to the right. So it shifted right 2 units. You could also say that k equals 2, or that it just shifted 2 spaces. Okay, however it wants you to enter that. Here is example number 1 in the next section, because this lesson never dies. Use the functions f of x equals the square root of x and f of x equals the square root of x minus 2 to answer the following questions. If the function f of x is equal to the square root of x is translated and rewritten as f of x is equal to the square root of x minus 2, how has the graph of the original function changed? So the only thing that changed was this, which means that the graph moved opposite, so that way, right 2 spaces. The graph has moved 2 units to the right. Second question, where is the x-intercept of the original function located? And where is the x-intercept of the translated function located? Now, if you were really struggling and you didn't know, you could go ahead and graph these, and then that would tell you. But if you stop and think about it for a second, this right here is a parent function. What does that tell you? It always touches or crosses through the origin. So the x-intercept of the original function is 0. Okay, so where's the x-intercept of the translated function? Well, it's moving opposite, so it's moving right 2. So the new x-intercept is going to be 2. See? We have 0, 0, and then we have 2, 0. Here's question number 3. If a point on the original function was 4, 2, where is the corresponding point on the translated function? We are moving right 2, and the only number that changes is the x value, which is right here. So 4 plus 2 is 6. So our new point is 6, 2. Da, 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 da. Here's question number 4. Sketch the graphs of the original and translated functions to compare their shapes and locations. Again, I don't think there's anything on the quick check or the practice that makes you graph, so I'm not going to bother to show you that unless I need to. So, and look, it doesn't show you the graphs, so guess what? I don't care. Example number 2. Use f of x is equal to the square root of x minus 2 as the original function. So we're not starting with a parent function now, we're starting here. If this function was translated 5 units to the right, what will the new equation be? So we're writing a new equation. This is our original equation, and we're moving 5 units to the right. So we're going to add something onto the end over here that's a 5. If we're moving this way, it has to be opposite, so it has to be a negative 5. So it's going to be all this nonsense, and then it's going to have a negative 5. What you have to figure out, is it outside the square root sign, or is it inside the square root sign? It's inside the square root sign, okay? Because it's part of this of thing, it has to go inside the square root sign. So this would simplify to negative 2 minus 5 would be negative 7. So this would be your final formula. Describing the transformation from graphs. Below is the graph, no it's not, of f of x is equal to the absolute value of x plus 1. It is translated from the function f of x is equal to x minus 1. Use the graphs to describe the translation. Okay, here's our 2 graphs. So this is x plus 1, this is x, absolute value of x minus 1. So it wants us to describe the translation. That's all we're trying to do, is use words to describe it. Shouldn't be too hard. If you look here, we started at minus 1 and then we moved to the right 1, 2 units. So in this case, k equals positive 2, because that's the direction that we're moving. The size and shape all stayed the same. Okay, so I don't know why I had that. I guess it doesn't matter. The vertex in the original was at negative 1, 0, and into the new one it's at 1, 0 because it moved 2 units to the right. Here's example 3. The graph of f of x has an intercept at the point 4, 0. It is translated using the new rule y equals f of x plus 3. What happens to the x-intercept? Okay, so we know we started at 4, 0, and we know our rule is that we're adding 3. Okay, but this has to be opposite. So it's really 4 minus 3, which is going to be 1. So our new point is 1, 0. You just have to watch that opposite thing. Okay. Here's example number 4. The function f of x contains the point 210 and is translated to g of x is equal to f of x minus 4. Where does this point get mapped to? So we have the point 210. The only numbers that change is the x value. We know we're dealing with negative 4, but we have to flip it. It's opposite. So we're doing plus 4, which is going to give us the new point of 610. Okay, as long as you remember to do the opposite, this stuff is not hard. Okay, example 5. The graph, which is not there, represents the function f of x is equal to x plus 3 squared. If this function is translated to the function g of x is equal to x plus 5 squared, how has the function moved? Will the y-intercept remain at the point 0, 9? Explain your answer. So here's our beautiful little graph, okay, and it's getting moved to x plus 5, okay? So how has the function moved? Well, we can tell right here because it went from plus 3 to plus 5. The change was 2, but it's opposite, so it's minus 2, okay? So it started here, and it's going to come over here, and this is going to be its x-intercept now, is at negative 5, okay? And it's still going to have the same shape and everything, but it's going to be something like that. So it wants to know, will the y-intercept remain at the point 0, 9? Well, obviously not, because it moved over. It doesn't get to just suddenly become like super fat so that it can reach 0, 9. That doesn't work. Okay. So, and that's what this big long explanation. It's all good. Question number 1. Oh my gosh, it got rid of my IN picture. That is worth fixing. My goodness. Let's fix that. It's his birthday today. He's half 50. He's 25 today. All right. So the function f of x is equal to the cube root of x plus 1 is translated using the rule f of x minus 7. Will the x-intercept be positive or negative? Explain your answer. This is all you. Pause it, figure it out, come back. Okay. We know the thing. This is our original formula. Okay. And the important thing is this plus 1. Okay. Which means that the x-intercept, if it holds true, I doubt myself now, should be negative 1. And then it's f of x minus 7. But everything gets flipped, so this should be plus 7. Negative 1 plus 7 is going to give us 6. Okay, so will the x-intercept be positive or negative? It should be positive. Let's go see if I'm correct. Yes, it will. I am so smart. I can't believe I got something right. That's kind of really scary, but guess what's gone again? The stinking graph. Okay, this is question 2, and this is all you. We're missing an IN pick. The function f of x is equal to the absolute value of x minus 1 is translated 5 units to the right. Okay, so this is our original, and now it's being translated 5 units to the right. What is the equation of the translated function, and where will the point 4, 3 be mapped to? So this is a two-part question. First, it wants to know what the new equation will be, and then where this point will be. Pause the video, figure it out, come back. Our new equation is going to be f of x is equal to the absolute value of x minus 1, and then our new information. 5 units to the right would be this way, but we have to do the opposite, so it's minus 5. Okay, all of that information, but this part can be simplified. So now it's f of x is equal to the absolute value of x minus 6. That's our new formula. So given that information, where is this going to move? Okay, if we have negative 6, that means we're moving to the right. That means that our k value is a positive 6. So we actually have 4 plus 6, which is going to give us 10, 3 for our new point. Okay, and you can see here we have, this should be x, not f. I apologize. And it should be, it says it's 9, 3. Is that what I got? I got 10, 3. I think that's probably a typo. Practice question number 3 at the very end of the lesson. Write an equation that describes the function f of x is equal to x plus 1 cubed, shifted to the left 3 units. Pause it, figure it out, come back. So we know that being shifted to the left means it's going that way. 3 units, which means k is equal to negative 3. So our new formula is going to be f of x is equal to x plus, it would be, we're going to take all our steps, it would be x plus 1, and then we have minus 3. That's our new k value. Plus 1 minus 3 gives us minus 2. So this one right here would be, oh, look at how weird they've got this written. So I guess this would be plus 1, and this one would be plus negative 3. I'm guessing that's how they want that written. Quick check question number 4 at very end of the lesson. Oh my gosh, we're almost done. Hallelujah. Which of the following best describes the transformation that occurs when changing an equation from f of x equals x squared plus 1 to f of x is equal to x minus 3 squared plus 1? So what changed between these two formulas? Okay. Obviously, it's this, because 3 is common in all of your answers. That means k equals the opposite of negative 3, which is 3. I'm not cheating because that's in all of the answers. So what you have to figure out is which direction it moved. If it's a positive 3, did it move to the right or to the left? And then you have to figure out, is it going to be half as wide? Is it going to have the same shape? Okay. Is it moving to the left or right? You can do this. I believe in you. Don't think too hard. On this, remember, we already did the opposite. We already got rid of the negative. Don't get tripped by that. Quick check question number 5 is missing its graph. Okay, the original function y equals f of x in the solid graph line, so this is the orange line, is the original function. Nope, goes through the point 1, 1. Yep, it does. So this is the original function. And it's translated using a horizontal translation. We're going from orange to blue. Where is this point, 1, 1? I will mark it for you. Where is this point right here located after the translation? And what is the translated function? So the first part right here is, where did this point move? Where is this new point? So figure that out. And then what is the new function? We started with y equals f of x. And we know we moved, so we have to do something. We know we moved 2, 1, 2, okay? So we have to either minus 2 or add 2. You have to figure this out. I believe in you. You can do this. Hallelujah. It's over. And it cut out my iron again. And I am so tired. I'm not going to go fix it because he's actually getting 2 lessons. There's a difference between baby bread and daddy toast. I like baby bread. Baby bread makes me smile and makes me feel safe. Daddy toast scares me.